Welcome back to the beginner game programming tutorial. This is lesson 4 and I am Chili. Now I've got a lot planned for this video, so let's get right to it. First thing, I want to make this text larger. I'm gonna make it this big. I think that will be better for you guys watching on YouTube and following along. If on the off chance you prefer the lower level of magnification for some reason, just let me know in the comments and we'll see. Maybe I'll put it back, but I think that this will be preferable. Now in the last video we learned about variables. We learned how to make them, and we learned how to use them. And we also learned about the addition operator, which basically takes a number on its left, takes a number on its right, goes nom nom nom, and poops out the sum of those two numbers. Very simple, very intuitive. Okay, the last thing was that I showed you, well, how to use the addition operator and the variable to offset some base coordinate of our of a pixel in our image here, our sprite. So we used that to be able to move the x coordinate, to move our sprite to the left or right, and then I gave you the mission to do the same for the y coordinate so that we can move it up and down. And this is the result of that task. So you should have something similar to this. Let's just run it just to be sure. Here it is. Here's our crosshairs. And by just changing these two numbers, we'll go with 400 here. We'll go with 400 all around. So I'm changing our dx and dy from -100 to -400, so it should move our cursor closer to the top left corner. And indeed it has. Alright, mission accomplished. So that was last lesson. One more thing I want to talk about before I get onto the topic of this tutorial is in the last lesson I started off by naming the variable x, and halfway through I changed the name to dx. Now the reason for that is because dx stands for delta x, or displacement x. So when I changed that, I was no longer representing the actual x location of the graphic, but I was representing a displacement from some base position of the graphic. In this case, the base position is at 700, and then we take displacements from that position. But a good question you might ask is, why choose 700? What reason is there? And the answer is that there is no reason. It's completely arbitrary. I just happened to be at 700 because that's the position I was using from the last lesson. But in reality, there is no good reason to base your graphic at some arbitrary location. So if you don't have a real good reason, and I can't think of one, to base your graphic at some specific location, you might as well just put it at 0. And that's what we're going to do. We are going to locate the base position of our graphic at 0, 0. Right? Now if we do this, dx and dy isn't so much a displacement as it is the actual x and y position of the center of our crosshairs. So we can change the name of our variables from dx, dy to just x and y. And of course we'll have to change all of our other things here. So in the case of this put pixel, instead of being at 695, it would be at -5 with respect to the center of our graphic, which is at 0, 0. So this one would be at -5, and this one would just be at 0. So I'm going to modify all of these put pixel calls to make our graphic, our targeting reticle, centered around the point 0, 0, or the origin. And when I'm finished that, we will be back. Alright, I am back, and I've finished revamping our targeting reticle drawing code here. You may notice that the formatting is a little different than what I've been doing before. I've added some white space here so that all my X's and Y's and everything line up prettily. It makes it a little bit more readable. And you don't have to do it that way. It works perfectly fine the way I've been doing it up until now. You may wonder if it's alright to do it like this, and the answer is it's perfectly fine. You can format your lines of code, you can add white space wherever you want, because C++, it doesn't care at all about white space formatting. So I just want to talk about that for a while. It doesn't matter how much or how little space you put between your what do you call it? Variable names or delimiters or literals or whatever these things are. So you could put absolutely no space between any of this and build, and we see success, so no problems. You could also do something like this. You could put a bunch of space here. You could put stuff on different lines and like just totally fuck it up. This is the fuggliest line. This is the fuggliest statement I've ever seen. And as far as the compiler is concerned, that is a perfectly acceptable statement. As long as everything's there and it's in the right order, and you finish her up with a semicolon, it's all good. Now, although the compiler might not have a problem with that, it's not exactly the prettiest code in the world to read or understand for a human. So that's why we generally follow certain code formatting conventions, styles. It just makes it a hell of a lot easier to read the code. I've gone a little overboard with this. You don't have to go this far. This is just like, this is kind of bordering on OCD, but yeah, it's a good idea to format things fairly consistently. I mean, the other thing you could do is you could put all of your code on a single line. You could do it like this, where everything's like just lined up on one big long line. Look at that. Look at that line of code. And if I build it, no problem. That's beautiful. But again, very hard to read. So, the moral of this story is C++ does not give a rat's ass about white space. Here's a little SAT analogy question for you. White space is to C++ as Ron Paul is to what? Just a little something for you to ponder. Now, so this is our targeting reticle centered around 0, 0. and I've set my X and my Y to 400 and 300. So that should place the center of my targeting reticle at the center of my window. Ah, I pushed the wrong button. It didn't do that. Wait a minute. Okay, I think I fucked something up here. Let's see. Oh, what happened here? That's odd. Okay, that's not what I wanted. Let's try that again, folks. That's more like it. Okay, I don't know what happened there. It was weird. Mommy, I'm scared. Okay, so we got the targeting reticle, and it's at the center of the screen, and that is good. Now we can finally get on to what I wanted to talk about. So I'm gonna get you guys again just to type what I type in. I'm gonna type if KBD. This is an object, and we'll go with down. Nah, we'll go with right is pressed. And we'll say X is equal to what? 500. Alright, and that is it. Just 3 or 5 lines of code, however, 4 lines. I can't count with shit. However many lines of code this is, that's all you have to type in. And build it. There we go. Alright. Now, I'm not going to run this yet, and I don't want you to run it yet, because I want you to make a prediction just based on what you know about C++ up to this point, and what you know about the English language and computers in general. I want you to guess what this code will do, how this will affect the program. So think about it for a minute or two, give it your best educated guess, and when you're done that, click Start Debugging. And here's our window. So we've got our targeting reticle, and it's in the center of the screen, as usual. Nothing much seems to have changed, unless you happen to press the right arrow key on your keyboard, in which case it will jump the reticle to the right. In fact, it will jump it to the right about 100 pixels. And I hope that's not too surprising given the code that we have here. I mean, just reading the code, you can read it if right is pressed on the keyboard, X equals 500. Or in other words, if the right arrow key on the keyboard is pressed, set X to 500, which will, of course, move it right from its earlier position of 400. And that is exactly what's going on here. So this is a new statement. It's called a conditional, or a branching statement. And it follows the basic format of if, and then some expression, if some expression, some code. So how this works is, after the if, you will always have these brackets, and in the brackets you have an expression. Now the expression can evaluate ultimately to 2 different values, true or false. If the expression evaluates to true, the code within these braces is executed. It can be 1 line of code, or it can be 100 lines of code, it doesn't matter. But everything within these braces will be executed if the expression is true. If it is false, the code here is skipped and execution continues as if nothing ever happened. Now, what do I want to say here? That's about it, I guess. So what constitutes true or false? Well, we're not going to go into that right now, but true and false are the values that can be assumed by a Boolean variable or a bool. A Boolean variable is it's a variable, and it can be either true or false. I'm repeating myself now. Now, looking at our if conditional here, we see that we are calling a function. We can tell that because we have a name, and then we have some brackets afterwards. So this is it's a function call. And if we mouse over it, we see on our tooltip that the function call returns a value. This thing right here at the very beginning of the tooltip that says bool, that is the type of the return value. So we can tell from this tooltip that our function right is pressed returns a Boolean value, which means it returns a value that can be either true or false. It only has two possible return values, true or false. And from the wording of the function, we can assume that if it returns true, that means that the right button is being pressed. And if it returns false, the right button is not being pressed. So, yeah. What happens is when the computer gets to this statement, it calls the function right is pressed, and that function says either, yeah, the right button is being pressed, or nah, it's not being pressed. And if it is being pressed, that says, oh, okay, and then it goes in here and sets X to 500. Whereas if the right button at this point is not being pressed, this function will return false, and the if statement will be, oh, okay, and then it'll skip this. And that is basically that. It's not a very complicated concept here. We've also introduced a new object. Just as we use our graphics object to put pixels on the screen, we have a keyboard object which we use to check the status of our keyboard. So this represents our computer's keyboard. And we can call a function, and that function will tell us whether a specific key on the keyboard is being pressed. Now you can notice that these two functions are rather different from each other. In the case of our putPixel function, we pass it a bunch of values, and it changes some state of the computer. In this case, it changes the display contents of our window, and it doesn't output a value. If we hover over it, we see its return value is void, which means nothing. It doesn't return any kind of variable. So we feed it some numbers, and it changes the state of the computer in order to output some information to the user. On the other hand, the right is pressed function, we don't give it any information. It has 0 parameters. It takes 0 parameters. But what it does is it outputs a value based on the state of the computer. So it reads the state of the computer, well, the state of the keyboard, and it outputs for us a Boolean value based on the state of whatever key is associated with the function call. So these are two functions, but they're different kinds of functions, and they're kind of complementary to each other. This is a strictly output function, and this is a strictly input function. We'll talk more about different types of functions later on. Now, I anticipate that some of you might be a little mystified by how this program works. Up until now, our program has just drawn something on the screen, and that's it. It just draws something on the screen, just like crosshairs or a single dot. And that's it. So you could imagine that our program starts, does some initialization, then it comes to our compose frame function, draws its crosshairs, and then just sits around. And if you believe that that is the case, then the behavior we're seeing here would not make any sense, because what would happen is our program would come here, it would check if the right button is pressed, and if it's pressed, it would set X to 500. If it's not pressed, it would leave it at 400. Then it would draw our crosshairs, and then that would be the end of it. And no matter if you press the button later on, it wouldn't matter, because our crosshairs are already drawn, it's finished. It doesn't matter what button you press after that point. But the actuality is that this function is not just being called once. We're not just drawing the crosshairs once and then we're finished. We wash our hands, we're done, I'm going home. That's not how it happens. Actually, we are redrawing the crosshairs many times a second. We're recomposing our frame over and over and over and over again, many tens of times a second. And to prove that, I will run for you a little program here called Fraps. Fraps is a application used for screen capturing and for benchmarking, and it will display an overlay on a DirectX window. And the overlay will show the frames per second. Alright, so here we go. And I hope you can see this this pretty yellow 60 in the top left-hand corner of our window. That means that our application is redrawing the window 60 times a second, unbeknownst to the rest of us. And that is why, wait, let me give this window the focus. That is why when you press the arrow key, our cursor seems to jump to the right here, because it's constantly being redrawn. So when you're not pressing the arrow key, it's constantly drawn in the middle. And when you press the right key, the next time it's redrawn, it will be redrawn in 100 pixels to the right. Alright. And that's basically how games work. They just constantly redraw the screen as fast as possible, or as fast as is advantageous, which is different than other applications such as this text editor, which will only redraw the screen if it thinks that something has changed and it needs to redraw it. And then it will only redraw the portion that it believes has changed. So that's a little different between games and other applications on the computer. One last thing. I'm gonna get Fraps up here again, because I like it so much. Where's my pretty number? There it is. Okay. Yeah. So up here I have 60 frames per second. But if you tried to run Fraps on your computer with this application, you might get a different number. You might get 100 frames a second, or you might get 120 or 75. And that would just depend on the refresh rate of your monitor. Your monitor has something called a refresh rate, and that is the rate at which it updates its display contents, which is independent of the rate at which the application redraws to its window. So the way I have the program set up here it will not try to draw faster than the refresh rate, because that would be futile. I mean, what would be the benefit of drawing 120 frames if only half of them would actually be seen by the user? So the frame rate is capped at the refresh rate of the monitor. You can uncap it, but there's really no point in doing that. Okay, so I've babbled on a lot about various stuff, but the important thing is that now we can control the flow of our program. We can conditionally execute statements, which, in conjunction with some kind of input function, such as this function here, will allow us to start creating interactive programs. And that's the next step on the way to making a game type thing. So it's that time again. It's time for your homework assignment. I think you could probably guess what's coming up here, but so far we've implemented moving the pixel to the right when we press the right key. But if you type keyboard KBD and then dot, you will see that we have a whole slew of functions here for inputting. We have down is pressed, left is pressed, up is pressed. We also have space and enter. So what I'm going to get you guys to do is to implement the other direction keys, so that when we press up, the crosshairs will move up by 100 pixels, and likewise for left and down. That shouldn't be too difficult, but I also am going to give you a one more task, and that is that when the space bar is pressed, I want the crosshairs to change to red. So not only will we be able to move our crosshairs, but we will also be able to change their color. Oh, the power, it's intoxicating. Yeah. So that is your task. And just for shits and giggles, I will show you here what the application should look like when you have completed it correctly. You should be able to have something like this, where you can control the position of your cursor through any of 9 possible positions. And if you press the spacebar, if I can find my spacebar, I think it's here, the cursor will turn red. Oh, isn't it beautiful? If you try hard enough, I think, let me just see if I can do it here. I think you could trace out, yeah? You could trace out a beautiful, beautiful swastika.